Okay, this one says that Marco decides to experiment with making his logo blockier so that it looks stronger. Here's what he came up with. So he starts again with the same size 1, but then this time he's going to make it like chunkier in both directions. So it's going to be longer this way and longer this way, but also taller in both directions, like in all directions. And then again, holy shamoly, it's getting bigger and bigger and bigger. Okay, and so some things that I'm noticing, and it helps that we've already done the first one. Some little things that I'm noticing are that if with size 1, you've got 1, 2, 3, 4, 5 ones. Okay, when it's size 2, you have 4, 4, 4, 4, and 4. And then when it's size 3, you have a 9, 9, 9, 9, 9. And something else that I notice is that instead of just having 2 extra squares, we have 4 extra squares. Do you see that? 4 extra squares. 9 extra squares. 9 extra squares. So it's kind of interesting. Maybe we don't consider them anymore as 9 extra squares or 4 extra squares, but we just consider it another grouping of interesting. Ooh, maybe we just do that. Let's go back. Kind of cool. I think you could just go like 1, 2, 3, 4, 5, 6, 7, 7 sets of this number. And 1, 2, 3, 4, 5, 6, 7 sets of that number. Okay, and 1, 2, 3, 4, 5, 6, 7 sets of this number. But if you notice, this is not, 7 sets of 2, it's 7 sets of 4. And it's 7 times 9. Okay, not 7 times 3. It's 7 times 4. And this is 7 times 1. So let's make a little bit of a chart and see what's going on mathematically here for a minute. So we have n is equal to, and f of n is equal to. So n is equal to 1, and f of n is 7. N is equal to 2, and f of n is equal to 7 times 4 is like 28. Yeah? And when n is 3, f of n is 63. Is that right? 7 times 9. Okay, so if we look at the first difference, first is, let's see, to go from 7 to 28, you have to increase by 21 plus 21. And to go from 28 to 63, let's do that really fast. 63 minus 28 is 35. Okay, so this one is plus 35. Okay, if we draw the next block, it would be, 4. It would be like 16, 1, 2, 3, 4, 1, 2, 3, 4, and it would be, it'd be 16s. So there would be 7 times 16. Yeah, this would be size 4. Size 4. So size 4 would be 7 times 16. Let's do that really quick. 7 times 16 is equal to 112. So f of n is 112. And then 112 minus 63. 112 minus 63 is 49. So this difference right here is 49. Okay, plus 49. So the first difference is not uniform. It's not constant. So this definitely, the formula for this trend is not linear, because if it were linear, these would be the same. So let's look at the second difference and see what's going on. Because if the second difference is the same, then we actually have a quadratic, which is kind of cool. So let's see, to get from 21 to 35, you have to add 14. And to get from 35 to 49, you have to add 14. Okay, so this is really cool. This is going to be a quadratic function. And something important about if I write down the word quadratic, okay, this word right here in Spanish means square, okay, which is kind of cool because every time you get a quadratic function, your function's going to look like this. F of n is equal to something n squared plus something, okay? Or it might even have like plus something n plus something. Okay, I think this one is simple enough that we won't have the center number. But quadratics look something like this. F of n equals n squared plus 3n minus 2 or something like that. This is a quadratic, and the reason you know it's quadratic is because of this. Because it is squared, like the word quadra is square. Okay, the biggest exponent in a quadratic function is a 2 because it's a square. Okay, let me erase some of this. Oh my goodness, there's a lot on here. I don't want to erase everything because it's just so much. Ooh. Let me try to erase some of this though. Okay, let's figure out what this is supposed to be though. Okay, quadratic. Okay, let's get some of this cleaned up a bit. I need a recording app that has a cool enough annotation software that I can lasso everything and erase it. But right now I don't. I only can erase with a little eraser tool, which is kind of lame. But that's okay. Let me see. Whoops. Okay. All right, so Marco decides that he wants to make this, and we found that when n f of n, oh dear, I erased everything. First, second, okay, we had 1, 2, 3, 4. This was 7. This was, what was it? 6 times 24, 28. This was 63 and 112 or something. And the first difference was 14. This one was plus, let's see, not 14. Sorry, 21. First difference was 21. Whoops. Okay. Second difference was plus, it was like 35. This one was 49. Okay. And this one was plus 14 and plus 14. Okay. So you're getting this as being a constant, so it's quadratic. So let's see if we can figure out what this equation should look like. What I noticed is that the n was 2, but the number of blocks on each section was 2 times 2. So I was kind of thinking it would be something like n squared times some number. And that number would be 1, 2, 3, 4, 5, 6, 7. 7n squared. Okay? Like that. And I think that that's the whole equation that we have, because I don't think we need to add anything to it. Let's check it. So if we're trying to find f of n, so the number of blocks, and we have size 1, you'd have f of n, or f of 1 is equal to 7 times 1 squared. So f of 1 would equal 7 times 1. Okay, and f of 2 would equal 7 times 2 squared, which would equal, f of 2 would equal 7 times 4, which is equal to 28. Okay, and so we're getting the right numbers, 7, 28. Yeah, I think that that's going to work okay. So I think that this is the formula that we need. I hope that you're understanding some of this. You don't have to try to understand all of it yet, but it is kind of exciting to see that when there's a squared right here, this function is quadratic. When you're increasing both the length and the height on the diagram, it's quadratic. Okay, it means you're changing dimensions in two dimensions. Okay, when the second difference is constant, it's quadratic. Quadratic. Okay, and quadra means square in Spanish, so don't forget. All right,